Hey everybody, in this problem we're given some known rates of change and we want to find an unknown rate of change. Let me go over what we are given. So we are given two bikers, which I'll call A and B. We're given a distance from biker A to a town, which I'll call X, and another distance from biker B to the same town, Y. We're given rates of change of X and Y with respect to time. And we want the rate of change of the distance between A and B. Okay, so let me draw a picture of that. Two bikers, A and B. And we are given a distance from A and B to some town. This distance I'm letting be X. Distance from B to town I'm going to call Y. And the distance, the unknown, is this is I'm going to call it D. That's supposed to be a straight line. I'll make it a straight line. Okay. And let's say we are given X, Y, X dot, the time derivative of X, and Y dot, the time derivative of Y. And we want the time derivative of the distance between A and B. Okay. So let's do this problem. So the first step is to find a relation in any of these later ratio problems. Okay, let's find the relation that's here between my known variables and unknowns. So the distance D, D squared equals X squared plus Y squared. And notice I have here the variables whose rates of change I know, and I have the variable whose rates of change I want to find on also in this equation. Next step is to differentiate the relation. So using chain rule, I get that 2D times the derivative of D with respect to time equals 2x times x dot plus 2y times the derivative of y. And 2 is there everywhere, so I'm just going to cancel it out. Okay. Next step is to plug and chug. So let me say what the givens were. In the problem, given that x equals 40, y and x dot equals negative 10 miles an hour, and y dot equals negative 15. And I write down negatives because in this problem we were given that A is moving like this, B is moving like this, so that corresponds to decreasing x and y. Okay. So if I plug that in, I get that the d corresponding to a 3 and a 4 is going to be a 5. So I'm going to get 50 times d dot equals x times x dot x dot here is negative 10 plus y times y dot. Y dot is negative 15. If I solve for d dot, I get that d dot. So that's the next step. I solve for d dot. D dot equals, if I solve, I get negative 17. In our case, miles an hour. And the question specifically asks, how fast is the distance decreasing? Here I've given the rate of change of increasing. So the distance between these A and B is increasing at negative 17 miles an hour. So that means that D is decreasing at 17 miles an hour. Okay. Now note I was careful with my signs over here. You don't always need to be careful about it. It does make the problem a bit more complicated. But I don't know if you've done WebAssign. Sometimes they care. So, and sometimes it'll matter in the problem. So I was a bit careful with sign. D is decreasing at 17 miles an hour.